morning, everyone. I hope everyone is well rested and had a great trip here to Amsterdam to this awesome conference. I want to thank everyone for coming to my talk about Arrow towards 2.0. And I'm so excited to be here at KotlinConf and talk about Kotlin, functional programming, open source, and Arrow for 2 full days. But before we start, I want to briefly introduce myself. I've been working with Kotlin for about 8 years, since 2015. And you can find me on GitHub, where I primarily work on the Arrow project, but I also work on some other open source projects and organizations. I'm a principal engineer at CBI Functional, formerly known as 47 Degrees. And you can find me on Mastodon, Twitter, but my favorite place to hang out is the Kotlin Slack. So, what do I want to talk about today? This month, we celebrate the 10th anniversary of Arrow. So I want to talk a little bit about the history of Arrow and the decisions and changes we made over time. While I'm talking about these decisions, I want to talk a little bit about the complexity of functional programming, but take into account this is from a point of view from Kotlin, and all these opinions are my own, although I think shared by many in the Kotlin and Arrow community. I also want to talk about the importance of embracing the language, because I think embracing the language and building an ecosystem of libraries that work well together is not only crucial for the libraries and the developers using those libraries, but I also think it's crucial to the success of Kotlin and the language. I also want to talk a little bit about evolving open source libraries and APIs, which is a topic that I personally find very difficult. And finally, to wrap up, I want to talk a little bit about the ecosystem in and around Arrow and functional programming in Kotlin. So to talk about Arrow's history, we need to take a big step back. So we are in the year 2013, 10 years ago. There was a developer called Mario Arias, which was using Scala with Spring, and he was looking towards Kotlin for better and seamless interop with Java. And when he was moving to Kotlin from Scala, he realized there was a bunch of idioms and patterns that he was missing that he grew used to from Scala. So he built a library called Functionale to fill this gap in Kotlin. And a couple years later, there was a Spanish community group called Find Cinnamon that started a learning journey together. And they wanted to learn functional programming in Kotlin. And they did so by building a project called Cats. And the Cats project was heavily inspired by the type-level ecosystem in Scala. And as it quickly grew, they rebranded the project into Category so that the project could grow into its own. And during that same year, I started a learning journey of my own. And I was studying the topic of optics. And while I was doing so in Kotlin, I built a library called Optical. And when I publicly announced this project, the Category maintainers quickly approached me, and they invited me to a functional programming conference in Spain called Lambda World, and they asked me if I wanted to join forces to them. And I was super excited, and I rebranded the project to what is currently known as Arrow Optics. And very shortly after that, we also got together with the Functionale maintainers, because we saw that there was some overlap between Functionale and Category, and we learned and experienced from other languages, and having these libraries that have overlapping functionality and duplicated implementations caused some friction in the ecosystem, and we wanted to prevent that. So, since none of us wanted to impose a name, we started a new open source organization and rebranded ourselves to Arrow. And the goal of the Arrow organization was to offer uniform and idiomatic functional programming for everyone in Kotlin. So that is what we set out to do. And so we are now somewhere in 2017 in what I call the pre-012 era. And in the pre-012 era, the Arrow library was very heavily inspired by Scala, and it heavily relied on type classes and higher canon types. 2 features that we do not have in Kotlin. So without going too deeply in how these things work, I just briefly want to show you some code to show you what code written with Arrow looked like at the time. So here we have a GIS API and a logger, and both are defined over this generic type f. And we can see that in the return type of our functions, we have this kind type that represents higher canon types. And we also have this list k type that was a higher canon type representation of the Kotlin list type. And you can see that overall, this Kotlin code is looking very foreign. It looks very non-idiomatic, and it was typically very hard to explain to people. And you can see that at the call side, we again have some complexity. So here we are calling the GIST API for the project reactor monotype. And you can see that at the time, we had to call this fix method to fix the higher kind of type representation, because this was a feature or a language feature we do not have in Kotlin. And we could then extract the mono value from the higher kind of type representation to then find it on the code. So you can again see it's very foreign, it's complex, non-idiomatic, was overall not very user-friendly. So why did we have these concepts in Arrow? We need to take into account that we are in 2017, and Kotlin structured concurrency was not yet announced at the time. Right? And the reason that we were using higher kind of types and type classes was from mimicking functionality that we knew from Scala, which was to abstract over the runtime or the framework. As you can see here, we are calling the same GIST API for the Arrow IO tab, which has now been removed, for the deferred K higher kind of representation from Kotlin X coroutines, for Eric's Java single, and so on. But as you can see, again, it's quite foreign looking and non-idiomatic. So that brings us to the 0.12 version. And when Kotlin structured concurrency was announced in September 2018, it was for us a huge step forward, because we realized that Kotlin coroutines and structured concurrency solved many of the problems that we had. So in the 0.12 version, we deprecated higher kind of types and type classes, and in the 0.13 version, we removed them. And when we removed them in the 0.13 version, we were all of a sudden also able to support Kotlin multi-platform. So we are now late 2018, and we are supporting Kotlin multi-platform, which was at the time quite early. So this to us also proved that we're heading in the right direction by embracing the language more and by moving closer to idioms of the language. So to summarize, some of the complexity of functional programming within Kotlin. Originally in the pre-0.12 era, it had an extremely steep learning curve. And it was very non-idiomatic and typically very hard to explain why you should be using these concepts. And if you were already familiar with the style of programming in, for example, Haskell or Scala, this style might feel familiar to you, but that was not the case for Kotlin developers. And we were using concepts, foreign concepts, that did not have first-class support in the language. Right? Higher kind of types and type classes do not exist, and perhaps rightfully so. It was causing some friction with tooling and the language and the ecosystem. And it was actually fighting against the goal that Arrow originally set out to achieve, which was to provide uniform and idiomatic functional programming for everyone, which we were clearly not doing at the time. So that brings us to Kotlin coroutines and Suspend. Right? So here we can see an updated version of the GIST API in the locker, and it's no longer defined over the generic type F. We do no longer see the kind types in the return type, and instead of using list K, we are now simply using the list type from the Kotlin standard library. And actually, there's no more arrow inside in this snippet, right? Which, in my opinion, a good thing. We are moving closer to the language, and we're supporting things in a more idiomatic way. Just to prove my original point, we are still supporting the same functionalities from before, or you are able to achieve the same goals by using Kotlin coroutines. So we can have a single Suspend implementation, and we can run that code using Kotlin X coroutines runtime, the project reactor mono, GDK8 futures, or any other framework or runtime that you might need to integrate with. But functional programming in Arrow is about much more than just I/O or Suspend or concurrency. So this brings us to the 1.0 version, the 1X series. And the goal of the 1X series, or the 1.0 version, was to support all these other functional concepts together with Suspend in a Kotlin idiomatic way. And another thing that I mentioned that we suffered from was a steep learning curve. So functional programming typically suffers from very large API surfaces and very complex API names and API signatures. And we wanted to do something about that. And we wanted to be able to truly mix and match and compose these other functional concepts, like, for example, typed errors, in combination with Suspend and Kotlin coroutines. So that's what we set out to improve in the 1x series. So here we can see a very vanilla piece of code with either. And this is a snippet that you can probably write in any language. And we have a GitHub user that we want to process, and it is returning either a processing failure or a processed user. You can see here that in the side of the function body, we have to explicitly wrap our return types with right or left to wrap these values into the either type. And while this snippet is probably non-idiomatic, and many people might prefer to use this style of coding for its explicitness, we felt that we could do better. So we set out to embrace DSLs in the Kotlin language. And here you can see a DSL from the 1x series, where you still have to use the eager function to differentiate between non-suspending DSLs and suspending DSLs. And as we will see later, this has now disappeared. And you can see that inside of the DSL, we have access to these specialized DSL functions. In this case, the ensure function, which is similar to the Kotlin require function from the standard library, but in comparison, the Kotlin require function throws an exception, where in this case, the ensure method raises a typed error provided by the Lambda. You can also see that there's no longer any need to explicitly wrap the values that we are returning in the DSL in right or left. We can just write inside of the DSL code that is very Kotlin idiomatic and that supports these concepts of functional programming like typed errors. And if you would remove the eager key or the eager function from the either block, you can also support these things together with Kotlin coroutines and suspend. So that brings us to traverse. And traverse is, again, it's a very popular function in functional programming, but we felt that it was still causing some friction. It was resulting in these large API services because we have all these specialized functions to work with functional programming within Kotlin. So here we want to transform a list of GitHub users, and we want to get either the first processing failure or the entire list of all the processed users. And in the 1.0 version, you had to use traverse. And the reason that you have to use traverse is that if you would have used map, you would not receive either the processing failure or a list of all the processed users. You would instead get a list of eithers, right? And the list needs to be inside of the either. And many people, again, argue that this is not really problematic to use traverse, but I would actually say the opposite. The running joke is that traverse is always the answer, and actually implies that many people tend to forget that you need to use traverse. And this is because when we think about transforming every element of a list, we naturally think of the map function. I think everyone in Kotlin and Java and many other languages are familiar with the map function, but not everyone is familiar with the traverse function. Right? So this causes some friction, and it increases the learning curve of working with functional programming in Kotlin. So that again brings us to the DSL. And if we are inside of the DSL, we can now simply use map. And our process function is still returning an either, so we can use bind to extract the happy path or the processed user from the either. And this is really great, not only because we can use map, but we can use the same pattern with any other collection API or any other API that you might be familiar with from the Kotlin standard library. Right? So this proves that we can use this concept of functional typed errors in combination with all the APIs that we are already familiar with and know from the Kotlin standard library. So that is truly great. So that brings us to the 2.0 version. And I'm very proud to share that last week we released the 1.2.0 version, and in the 1.2.0 version we support the entire API of the 2.0 version in a binary compatible way. And the 2.0 version will be released later this year, a little bit depending on the announcements of this conference. And the goal of the 2x series was to further reduce the learning curve of Arrow by providing a small and uniform set of APIs. And we can also finally get rid of this obscurity and complex API names and signatures that we inherited from the pre-012 era, like the traverse function. And it is thanks to community feedback and frequently asked questions during the 1x series that we were truly able to pinpoint the pain points of Arrow and work on them to improve the learning curve and the idiomaticness of the library. So let's see some final examples of how we can work with the 2x series or with the 1.2.0 API to solve some of these problems. So here is an updated example using the IDER DSL, and you can see that we no longer have to differentiate between the non-suspending DSL and the suspending DSL. There's now only a single DSL that works for both cases. And you can see that we are leveraging the specialized Kotlin DSL support to highlight the DSL's functions in a special color. So now when you're working with Arrow and functional programming in your project, it becomes much easier to spot which are the functions being used and which are the functions that are coming from Arrow. And we were also truly able to leverage Kotlin contracts in many more places to truly make working with functional programming feel more idiomatic and natural in Kotlin. So here we are using the ensure not null function, which similar to the ensure function is alternative for require not null from the Kotlin standard library. Again, it does not throw any exception, but it erases the typed error from the lambda. And when you have checked that the value is not null, the Kotlin compiler will now smart cast this value to non-null. And we are able to leverage Kotlin contracts in many more places to feel working with functional programming feel truly idiomatic and natural like you would expect within the Kotlin language. So historically, Arrow inherited a lot of complex API names from functional programming. And other languages like Haskell, in my opinion, have a very good reason for its more obscure API names. But this is truly not the case for Kotlin, especially not since we removed type classes and higher canon types. So by getting rid of our history, we actually no longer had this reason for having these more obscure API names. And together again with the community feedback and community discussions, we came up with a set of names that felt truly familiar within the Kotlin language. And here you can see an example of some of the APIs in either type that are actually inspired by the Kotlin result type. So if you are already familiar with the Kotlin result data type from the standard library, these functions should feel somewhat at home to you. So this brings me, I think, to my favorite slide of the entire talk, and my most anticipated feature in Kotlin, which is context receivers. And when we are using context receivers, we can actually even get rid of this either wrapper that we were seeing before in the return type. So here, from the process function, we are simply returning a processed user or the happy path from our function. By annotating our function with the context keyword, and by using the raise type inside of the context receiver, we are here declaring that this function can raise a typed error of the type processing failed. So the caller of this function either needs to redeclare that it can result in a processing failure, or it needs to deal with the possibility that this error occurs. And this is really neat because inside of the method body of our function, we still have access to this DSL that we saw before from Arrow. So here we again have access to ensure not null, and all the other DSL functions that are available. And we can also see that in the function below, where we have our what was previously traverse, we are redeclaring that this function can result in a typed error of processing failed. And inside, we can simply use map to transform every element or process every element of our list of GitHub users. We can also see that since we're not returning either anymore from our process function, we also no longer have to call bind. So a lot of the complexity of functional programming is actually now disappeared. We have no more wrappers in the return type. We are simply returning the happy path from our function. We have no need anymore to call bind. We have no need anymore to explicitly wrap our values in left or right or other data types. We can simply use code that looks very Kotlin idiomatic and could actually be used in any other exception-based code, simply by, instead of using exceptions, annotating our function with the context receiver of processing failed. So I think this is truly revolutionary for functional programming in Kotlin, and I cannot wait for context receivers to be released. And this concept of functional DSLs does not only apply to typed errors. So here we see two examples, and in the first example is a topic that I've extensively talked about in other talks and webinars, which is the concept of resource safety. And here we define a function on the resource scope, DSL, which you could have also put in the context receiver. And inside of the method body, we get a DSL available to us for working with resources. And in this case, we're creating an Hikara data source, and we are wrapping it in a closable constructor. And this guarantees us that whenever we are running our code in a resource DSL or resource block, that we get guarantees over that the resource will be closed and finalized, whether we face cancellation, any exception, or our program finishes safely. And in the second function, we can say the same pattern applied for the Saga pattern, which is common in distributed systems. We can define an action and a compensating action. And the Saga scope or a Saga DSL or the blocks will guarantee that when all the actions have run and something goes wrong, that for all the actions that have run up to that point, all the compensating actions will also run. And this is truly interesting because here we can see that neither of these powers or functional concepts imply a return type or a wrapper around our values. So we don't have to return a resource of the Hikara data source. We don't have to return a Saga of a string. We are simply working with DSLs. And what is powerful about this is that together with the raised DSL and Suspend and Kotlin coroutines, we can truly mix and match and nest and compose all of these concepts without having to impose deeply nested wrappers or complex techniques like monad transformers to make these things work nicely together. So we can forget and get rid of a lot of the complexity of functional programming and still benefit from all the things in the type safety that we love from functional programming. So I already mentioned a couple of times that a big goal for us was to reduce the API surface in order to also reduce the learning curve. And this has a nice side effect, pun intended. And we can see that in the 0.11 version, the binary size of Arrow was 4.1 megabytes. And this was a concern for many people, and rightfully so. 4.1 megabytes is quite large. And in the 1.0 series, we truly did the best to reduce the binary size of the Arrow library, and we were able to get it down to 3.1 megabytes. And to give you an idea, this is slightly below the binary size of Kotlin X coroutines, but I still felt that it was quite large for including these functional concepts into your projects and libraries. But I'm very excited to share that in the 2.0 series, we were able to cut this down to 400 kilobytes, or to almost 400 kilobytes. So this is a 10x decrease compared to 6 years ago, where we were in the pre-0.12 era. So I think this is truly wonderful because this makes Arrow a much smaller risk and much less impactful to include in your libraries, application, and any software that you might be building. This also brings other benefits. Due to the smalling learning curve and smaller API surface, the smaller binary size, this also comes with less risk of binary breaking changes. The less APIs there are in Arrow, the less things we can break. So this makes the success of Arrow more guaranteed towards the future. So this brings us to the topic of evolving APIs. This is a topic that I personally find very difficult. Thanks to a lot of feedback from the community and having a lot of discussions and interactions, like frequently asked questions, we're truly able to pinpoint the difficult areas of Arrow. And we were truly able to do something about them. And as many of you might know, iteration makes perfect. We didn't get it, in my opinion, right in the pre-0.12 era. We did a lot better in the 1x series, but I think we've been truly able to get it right in the 2.0 version. And as many of you might have also experienced, learning new languages is not always easy. While you can be productive within Kotlin within days, it takes you quite a bit longer to get familiar with all the ins and outs of the language and all the tricks and cool patterns you can apply when working with Kotlin. But all of these improvements, they do not come without a penalty. And the penalty is breaking changes. And this is a burden I personally find very heavy to bear. Breaking other people's code is something I do not enjoy doing. But sadly, it is something that we have to do sometimes to make things better for everyone that wants to do functional programming in Kotlin. So what are some of our options to deal with these breaking changes so that nobody's left behind on older versions of a library? And the most obvious and most straightforward solution is probably the add deprecated method. And with the add deprecated method, we can add a description as to why an API is being removed or replaced. We can also add a replace with statement that describes how you need to refactor from the old API to the new API. So in this example, we have the handle error with API, and we want to refactor it to the recover DSL-based API. And if you are working in IntelliJ, you will now see that the handle error with method is stricken true, and that IntelliJ will suggest you, if you open the action window, to automatically refactor this function. And IntelliJ will also suggest you to do this for your entire project. And while this is really neat and really powerful, we've learned through experience that this does not apply to all cases. It does not work for all and more complex signatures. It also does not work for all different kinds of usages that you might find at the call side in your projects. It also doesn't seem to work consistently across all versions of Android Studio and IntelliJ. And while this is a really neat feature and it can really help people move forward, I felt that we needed to go a step further to solve this problem. So a couple of people suggested to me the OpenRewrite framework. The OpenRewrite framework is a project that originally was invented at Netflix and is currently being built by a company called Moderne. And the OpenRewrite project allows you to do large-scale refactoring for your code base. And currently, the Kotlin support is still experimental, but as I will share in the next slides, they are able, and thanks to our help, able to stabilize it very quickly. So let's see how we can use the OpenRewrite project. It's quite easy. We can just add the OpenRewrite Gradle plugin to our plugins block. We add a dependency, in this case, on rewrite arrow. And this rewrite arrow dependency includes some recipes similar to the replace with statement that describe how OpenRewrite needs to refactor the code from the old DSL to the new DSL or other APIs. And then within the rewrite configuration, we specify which recipes or which replace statements we want to activate. And in this case, I'm activating the race refactor recipe, which will rewrite the entire code base from the old DSL to the new DSL. And when we have this configured, we can quite easily run the rewrite run command, and it will process all the files in our project, and it will then list all the files that it's rewritten and list the recipes that it applied to those files. So this allows us to quite easily refactor and keep our projects up to date using the OpenRewrite framework. So I think this is a truly powerful tool. And to summarize, so the OpenRewrite framework allows us to do large-scale refactorings in an automated way. While the Kotlin support is still experimental, it is stabilizing extremely quickly. And the community is extremely friendly and helpful, and whenever I reached out to them with any problems or bugs, they were typically fixed within a day or two. So I want to invite all of you to try the rewrite arrow recipes on your projects and report any bugs or issues that you might encounter so we can stabilize this really powerful tool within the Kotlin language at a fast pace. Because I think it's a tool that we are truly missing in the community. And while the Kotlin support is still experimental, it does already support both JVM source sets and common main source sets. Sadly, it is not supporting JS or native source sets, but it is on their roadmap. And I'm also happy to share that the race refactor recipe that I showed before is already finished, and I was already able to apply it to some of my projects. We are also working heavily on some other of the recipes so that everyone can automatically refactor from the 1.2.0 version to the 2.0 version when it will be finally released. So this brings us to documentation. And with all these changes and all these new shiny APIs and this new shiny version of Arrow comes a brand new website. And documentation for open source project is truly crucial. And while the old Arrow documentation really emphasize on technical details and how things work. We reoriented the documentation to focus on how the Arrow can be used in the industry and how you can apply Arrow in your projects today. And this is a page that I also found very interesting. We've written a very extensive migration guide. And the migration guide does not only support you when you need to rewrite your project to the new APIs, for example, when replace with or OpenRewrite are not working for you, but also serves as a kind of a design document that explains why we have changed these things in the 1x series and why we are removing some of the complex things of functional programming in order to provide more idiomatic APIs. So if you're wondering why these things have changed or why we are going in a certain direction, this migration guide should help you understand all the changes and decisions we've made in the last couple of years during the 1x series. And finally, we've also added a new page, which is the ecosystem page. Like I mentioned in the beginning, the goal of Arrow was to truly offer uniform and idiomatic functional programming for everyone. This includes everyone in Arrow and outside of Arrow in the functional programming community. So in the ecosystem page, you are listing all the libraries that are built with or without Arrow and that support functional programming in Kotlin, because we want to make a central place for everyone to learn and find out about these projects in Kotlin. And I want to invite all of you that are building functional libraries in Kotlin to reach out to us so that we can include your libraries on this page, so that we can truly facilitate functional programming for everyone. And finally, I want to thank everyone for using and believing in Arrow, not only the contributors, but also all the people that have provided feedback, that have interacted with us, and that have helped us become Arrow what it is today. And I want to invite all of you to the Kotlin Slack, where a lot of us hang out in the Arrow channel. And we have a lot of very interesting discussions there. So for everyone that's not yet on the Kotlin Slack in the Arrow channel, I want to invite you there and join us. And for everyone that is not on Slack and has some issues or feedback, I also want to invite you to come by the GitHub repository and have discussions with us, and we'll be very happy to help you with whatever issues that you may have. Finally, for everyone here at KotlinConf, I also want to say that we have an Arrow booth where you can find me for the next 2 days. We'll be more than happy to discuss any questions that you might have. And I want to explicitly thank CBI Functional for building the new website for us and for sponsoring and believing in the Arrow project for all these years. Again, I want to thank everyone for coming to my talk, and I want to thank everyone that is helping organizing this awesome conference. And please don't forget to vote for my talk.